is a compact version of G120. C stand for compact. Okay, compact ni semua embedded sekali. Okay, when you talk about G120 standard ni it's a modular design, which means your power block, dan ini power block, control unit, operator panel, semua cabut. So you can order the standalone CU, standalone power block or standalone operator panel. Standalone satu. Okay, then you merge together. The control unit is a common one. Tak kisah you pakai motor 0.355 sampai 27 MW pakai CU yang sama. Control unit yang sama. Operator panel pun sama. Kalau compact tak ada. Compact memang sekaligus. Ni dua ni sekali. OP je boleh cabut. Yang ini sekali. So kalau rosak, contoh control unit rosak, kena tukar power block sekali. Ini tak ya. Control unit rosak, tukar control unit. Power block rosak, tukar power block. Okay, so this is a compact and simple installation for the smaller space lah. Tapi compact tapi lain kecil, compare dengan yang general model. Okay, G120 basically is a high degree of flexibility and combination lah. Dia boleh cabut lah. Journey X, okay, basically this is the application lah, macam HVAC. Ya, H, V, A, C.
Aircon.
Heating, ventilation, air conditioner and cooling.
Oh, lain. I ingat AC is aircon.
Aircon tu aircon. Cooling boleh tanpa aircon. Macam lebih kurang kan, tapi lain. Untuk industri lain, cooling is cooling. Aircon is aircon. Aircon with compressor, cooling without compressor. Okay. Application, tak payahlah. Basically ini untuk cover lah, dia punya blur sangat lah gambar.
Itulah.
Cover, okay, basically this is the industry lah, the cover. So for V series, basically it cover the basic. G series is covering the medium. If high is covered by the S. Basic, medium and high lah. Okay, ni nampak sikit. So tengok, V, sini medium atau non-continuous. There's a continuous motion dengan non-continuous motion. The application lah. Tapi sebenarnya sama je. Okay? Tak kisah, basically based on the, bukan based on the application, based on the customer selection. Dia nak pakai apa? Kalau I nak pakai untuk conveyor tapi nak pakai S, boleh. Kenapa tak boleh? Boleh.
Takut dah mahal.
Mahal je. Macam kereta lah, you nak beli Perua ke nak beli Merc ke, sama. Jalan-jalan. Nak highway boleh. Nak pergi mana? Boleh. Pakai sama je. Okay, this is a system design on the application. On the external modules. Or there's an accessory for the inverter. So basically there's a few cover lah. Okay, first it's a line side. Line side means incoming side. This is inverter component and DC link. Load side, outgoing, and the supplementary component. So for line side basically is a protection lah. Line side here. Sebelum inverter. Load side after inverter. Simple. And supplementary, ini supplementary. And DC component. DC component okay, fuse. Semiconductor fuse. Basically it's a power limiting fuse lah. Ini another one we call HRC fuse. High reacting current fuse. HRC. Okay. Okay, so basically why we need the fuse control? Memanglah compare dengan breaker dengan inverter, siapa mahal? Mesti inverter lain mahal. So we need the fuse protection dulu ya. In case anything happen, ini pakai. Tapi dia ada spek ni. Dia tak boleh pakai fuse buzzer. Mesti pakai HRC fuse ataupun semiconductor fuse. Okay, so biasa HRC fuse ni dalam tu akan isi dengan pasir. Sand. But the sand dia bukan pasir yang biasa. Okay? Okay? Why we need this? Because we don't want the copper plate inside. It's dependent on the temperature. Okay, so for commonly we use lah. If you using normal fuse, biasa dalam tu kosong ni. Dia satu copper cable habis kat depan. So ini ada masalah. Kalau panel panas, dia lagi cepat dia lagi putus. Kalau sejuk lagi lambat dia putus. But my inverter duty operation from negative 40 up to positive 70. So we need a semiconductor. Usually they fill some sand inside. So the external temperature and also the casing will be ceramic type. So the external temperature won't affect the copper plate inside. Okay, so why we not recommend using it because basically there's disconnection time is lower. We're talking about disconnect time. How much the time? I teach you before I remember. Contactor switching circuit breaker switching time compared with the phase switching time. Okay, sekarang ini putus berapa lama? Ini switching berapa lama? When they detect overcurrent. How long is the switching time? Try to figure out values. Siapa paling dekat, siapa belanja makan. Tak, siapa paling jauh, siapa belanja makan. We talk about MCB switching time lah. Simply say, biasanya ini pakai untuk MCCB. Jangan kata besar lah. Kalau kecil punya, we talking about 30 milliseconds. 0.03. Kalau besar pun, kalau breaker besar, we talking about 0.06. 60 millisecond or 110 millisecond. Depend kepada brand lah. But based on study, it's like about 30 millisecond. But for fuse, 10 millisecond. Nampak macam beza je. Macam tak beza tinggi kan? But 3 times. Okay? 3 times ni can cause your power block failure. Ini overcurrent putus je. Ini kena tunggu dia react. Kena spring dulu tenang baru dia ke sikit. Itu lah, nampak lah. Walaupun dia laju.
Even 0.3 beza pun ada effect lah dekat komponen.
Ada possibility. Bukan kan kata ada effect, but they still slower. Okay, that's why usually when you base on this inverter design, usually when I talking about inverter 10 kilowatts, 20 amps right? But usually my breaker 4 times. I need to put a 100 amp breaker. Why? I don't want overcurrent to delaying the switching. Understand? Kalau lagi tinggi dia punya current, lagi lambat dia buka contact. Sebab dia punya spring tak cukup keras. So lagi lambat dia buka. Something like that. The concept is something like that. When you for time you try to study the MCCB structure, then you know what. Okay? MCCB also there is a thermal type or there is a ETU type. Kalau thermal type lagi lambat, thermal type dependent on the spring. Imagine when the current is pick up, you need to wait the spring react, then only turn down, baru dia buka. Kalau full putus je. Tapi masalah non reusable, this is reusable. Okay, lagi satu line filter, ENC filter. Okay, this is one of the very useful thing. Basically, this is to reduce the ENC backfeeding to your power line. Humidity, yeah. Okay, so usually there's a immediate emission, there's an emission current that will interrupt another system. Contoh satu panel, ada motor biasa, ada contoh ada PC, ada apa dekat dengan panel. Okay, so usually we need EMC filter. Basically, EMC filter also is LC filter. Embedded. Okay, so in solver environment is based on the domestic environment. Usually we're using a Class A filter. Industrial use Class A filter. Okay, for EMC emission limit, ini we have to study the ISO lah. They only know the EMC emission limit. Dia ada limitnya berapa persen maximum. Ini pun tak apa-apa. Saya banyak. Okay, line vector. So basically line vector is to stabilize the current. Simple. Just a transformer. Okay, smoother the current drawn by the inverter. Okay, EMC filter kerja dia filter ini untuk smoother, untuk cantikkan dia punya curve. Contoh yang ada interruption kat tengah kan, kat input line. Okay, usually we will put a line vector to smoother the incoming voltage. Okay, so and also the reduce harmonic component into the limit current and protect BFT from the power surge and transient. Ini power surge and transient caused by what? Usually caused by power switching. Selalu jadi apa? TNP switching. Kalian perasan kan kalau di rumah kan tiba-tiba macam lampu tu terang sikit ataupun kipas tiba-tiba pusing laju, okay, back to normal. This is causing what? Because they doing the make before break switching on the TNP side. Make before break switching is what? You got two transformer. You got momentary close within two transformer. So your transient will be big. Dia punya transient current dulu akan naik. Okay, sampai dia buka. Biasa kenapa? Dia nak service transformer. Contoh dua transformer, ini supply A, ini supply B. Okay, I nak service salah satu transformer. Then I got one coupler. So I can temporary tutup coupler, buka satu breaker untuk serviskan I punya transformer. Tapi I tak nak ada power interruption. There's two options, break before make and make before break. If break before make, I got power interruption. Mean I have to open one of the breaker, line sini tak putus lah. Baru coupler tutup untuk supply balik. So usually the transient happen when make before break. So coupler akan tutup sebelum dia buka. So in that moment lah, usually dia akan perasan tiba-tiba you punya pusing kipas tiba-tiba laju, okay, berhenti. Tapi kalau you ada power monitor, you akan nampak you punya voltage naik turun balik. Itu transient current. Okay, so that one will also affect your inverter. So usually this is like to protect only lah, protect the surge and the transient, but is then for voltage peak is still going to pick up. Imagine it's just a transformer, cannot do much. There's no control. This is a passive line filter. Okay, next power block. Power block basically is the one ini pekerja. Yang control ini untuk kepala dia, ni badan dia. This is a slave. Dia kerja je. Dia tak simpan apa-apa. Okay, so everything controlled by the control ini. Control ini adalah kepala dia. The brain. This is the body. They just doing the work. Without CU, nothing. Okay, so there's a two unit PM240 and PM250. 250 actually already obsolete. Okay, just now I mentioned right the converter part. There's two different type of converter. Standard one is using rectifier. This one using IGBT. When rectifier always one way. One way only. The voltage one way, current also is one way. If IGBT two way. IGBT two way means if let's say you got some energy generate backfeed from your motor back to your DC link, they can backfeed back to your power line for power saving purpose. Sebab motor, when the motor try to slow down, when the motor driving the drive, not the drive driving the motor, they will become a generator. Your power will become negative. Kalau dia tengok main drive akan jadi negatif. Walaupun current ada, tapi the power is become negative because the drive is driving the drive. The motor is driving the drive. Faham? So ini akan jadi satu generator. They will generate a magnetic field. The backfeed current will backfeed to the inverter. Your inverter will try to do something to waste out the energy. If you didn't waste out the energy, they will causing the voltage on the inverter because too much of voltage generated from the motor. So we have to do some setting to fine tune the motor, or we need to use some external component to protect it. One option, we use a PM250. Okay, the external energy can feed back to the supply line, no waste, and also reduce harmony. Tapi ini order, really obsolete. Too many issues. Selalu burn kat side. Ini control ini lah. Control ini basically ni sama je. Lebih kurang je. Ini is special. But ni ada encoder. For closed loop control what? Perform closed loop control function for the inverter. Oh no. Closed loop basically there is a two closed loop. This is the encoderless, this is encoder. Both are integrated with the circuit technology. Tapi standard pakai ni. Okay, braking resistor. Okay, braking resistor is what? Imagine there is a hoisting system. Senang radiator, elevator. Elevator, dia akan nak turun kan? Okay, so kalau perasan, when you try to hoisting system, when you contoh lift tu memang penuh orang, ada 10 orang datang. Tapi motor dia akan paling tinggi sekali. Tapi kabel tu okay, contoh 2 tingkat. Okay, when using a hoisting system, we got the brake. We got a motor holding brake. When the motor is magnetized, then only the brake will open. Then we transfer you to the floor. When they try to stop the motor, the brake will kick in. But imagine in this moment, when the brake is kicked in, the motor load is still there. So they will have a very big current generated from the motor, back feeding to your inverter. Okay? So when you didn't do anything, all the energy will store at this part, your capacitor parts. So how do we waste the energy? So we need something we call braking resistor. This braking resistor basically is very straightforward. It's just a resistor to generate the heat. Heat up. Banyak atas.
Ingat
Sama kan? Okay, braking resistor. Okay, kalau you perasan, biasa kalau macam kereta api pun ada juga. Kalau you perasan, next time you naik MRT, sebelah station ada panel kan? Panel ada banyak kotak-kotak macam dulu. Itu braking resistor. Braking resistor. Braking resistor basically, how do you braking resistor? Dia bukan on je. Okay, usually the inverter will generate the high pulse. Try to on untuk buangkan energy dia. They will waste the energy from voltage become heat. Dia akan bazirkan by the resistor. Lagi besar lagi banyak, the inverter ni kecil je. Ini kita cabut dari mana? Kita cabut kat side ni sebab terlalu kecil, tak boleh support. Sebab dia punya motor terlalu besar. So we upsize the size yang besar, yang lama tu kita cabut lagi. Ini buat kat mana? Disahkan budaya.
Saya dulu apa?
Jadi yang besar tu main stage. Dia punya stage tu bawah ada 3 tingkat.
Oh ya.
Satu tingkat 4 meter. Stage tu boleh turun bawah dan atasnya.
Stage tu?
Ya. Yeah. Dia punya stage tu, central stage tu ada 4.
Ada 4 ni.
Petaknya dia segi 4, tapi separate to 4 pieces. Yang 4 keping tu stand alone atap. Stage tu 2 tingkat ni tau. Dia bukan 1 tingkat. 1 tingkat 4 meter. Okay? Stage tu boleh naik atas stage 1 tingkat. So macam mana orang tu masuk? Biasa dia punya setup kan, dia akan masuk dari bawah, tingkat bawah, D1. Barang semua tolak masuk kepada stage tu, naik atas, barang keluar, kereta balik. Ataupun dia punya stage suite boleh masuk jalan. Dia punya wagon boleh jalan. Kita control tukar punya drive last time. Something like that. Sama lah dia banyak ni. Sebab dia pakai lift. Dia konsep sama macam lift. Dia akan gerak dia. Tapi dia bukan hanging dari atas, dia tolak dari bawah. Dia satu magazine modul, dia tolak stage ke atas. Okay, so braking system basically very common to use is holding system. Kalau mana-mana lift mesti ada benda ni. Joystick lah. Untuk